In this section, we take a look at the camera settings and all the related options to cameras in Arnold for Cinema 4D. And in this first lesson, we cover general settings and common attributes. Here's the scene we're going to be working with, a very simple house model from Cinema 4D's Canon browser. And this ground object, we have our abstract 3D object, which is hidden right now, and it has some animations in the form of rotation. And Arnold Sky that provides the lighting, and a simple Cinema 4D camera. To create an Arnold camera from the Arnold menu, you can go to Arnold Camera, and now you have access to different camera types that Arnold provides. Or you can simply right click on an existing Cinema 4D camera and add an Arnold parameter tag, and now you have an Arnold camera. Now before doing that, let's see what native camera attributes are supported by Arnold. By default, Arnold supports some of the settings from native Cinema 4D's camera. One of them is focal length, so let's use a wider lens like 15mm here. Let me move the camera a bit closer and we get this dynamic wide lens shot. Now press Ctrl+Shift+Z to undo the view and change the focal length back to 24 again. Also, Arnold supports field of view from Cinema 4D camera. You can adjust these values and see the result. The next supported options are film offset on X and Y. Also, you should define camera's focus distance and focus object. From here you can do that, and Arnold supports them. We take a closer look at focus distance in our next lesson when covering depth of field effect. Also, if I go to the detail tab, Arnold also supports near and far clipping features of native Cinema 4D's camera. So I can cut off through my render. Let's set the near clipping to something like 1400 and enable far clipping and maybe something like 1700. And as you can see, we only see the distance between 1400s and 1700s from our camera, and the rest is cut off. Let's disable near and far clipping and rerun the IPR. Now to adjust specific Arnold's camera settings, you need to add an Arnold parameters tag to your camera. So right click on the camera, C4D28 tags, and add an Arnold parameters tag. And the cool thing about Arnold parameters tag is that it is dynamic. So based on what kind of object you are adding this tag to, you would get related settings to that specific object. Now, if I select the camera tab and enable custom type, I can choose between different camera types like cylindrical camera, fisheye camera, orthographic camera, perspective camera, spherical camera, and VR camera. Obviously, you can create these cameras directly if you create your camera from the Arnold menu. Now, we discussed these camera types in the last lesson of this section, but in most cases we would use perspective camera. So let's disable custom type and go to the main tab for now. The first value, which is the most important value, is exposure, and it controls camera's exposure in a non-physical way. So as you increase the exposure by one step, you are doubling the overall brightness of the image without affecting the light and the shaders in the scene. So by increasing exposure, you are letting more light to enter the lens and therefore getting brighter final results. You can decrease this value, let's say to something like -2, and as we have less exposure, we are going to get darker final results. In other rendering engines like V-Ray, you have a bunch of settings that affect the exposure in a physically correct way, like ISO, shutter speed, f-stop, and you need to keep the balance between them. But here you have one non-physical control to adjust the camera's exposure, and in a future release they might add actually those physically correct controls, but for now this one exposure value is all we have. Filter map allows you to darken certain regions of the image. You can simulate effects like vignetting, for example. As you can see, we cancel the texture directly. First, you need to create an image node. So from Material Manager, Create menu, Arnold, Texture and Image. And let's open the image node and load this vignetting texture that I have. Now let's select the Arnold parameter tag that is applied to this camera and drag this image to the filter map field. And as you can see, the image is multiplied over our render and we get this vignetting effect. I would never use this here because I can very simply add this effect in Photoshop or After Effects or any other compositing or image editing app. But if you want to use it, there you have it. Let me clear this out. We have rolling shutter, which is used to simulate the type of rolling shutter effect seen in footages shot with digital cameras that use CMOS-based sensors. Rolling shutter direction specifies the direction that the rolling shutter takes place. With the rolling shutter duration parameter, it is possible to control the duration of exposure of the scan lines in a rolling shutter camera. Now let's unhide our abstract object here, and as you can see, it has a simple rotational animation. So let's go to frame 5. Also in the IPR, let's enable render region tool and just render this section around the object. Rolling shutter is a motion blur related effect, and in order to see how it works, we need to have motion blur enabled. So open up the render settings, Arnold render, under the main tab, go to the motion blur section and enable motion blur. To see the effect a bit better, let's change the motion blur length to about 3 and keys to about 5. Don't worry, we discuss motion blur in this section later on. For now, let me just close this window. Now let's see how different rolling shutter direction and duration values affect the overall motion blur look. Right now in the IPR, we just have motion blur, no rolling shutter. Let's set the rolling shutter direction to top and no duration. You can see the result in the IPR. Next, let's set it to bottom and no duration. Left and no duration. Right and no duration. Now, let's set the direction to left and duration to 0.25. As you can see, we get the motion blur itself back and we have rolling shutter going on as well. And finally, let's try left and 0.5. Okay, so that's about rolling shutter parameters. We have the sweet depth of field here, which we discuss it in depth in the next lesson. So let's skip it right now. We have UV remap, and for this to work, we need a lens distortion grid and making a UV distortion map from that. And this will allows us to have barrel and pincushion distortion camera lens effects. Also down here we have some shutter controls which are related to the motion blur effect, and we discussed them in the motion blur lesson of this section. I mean, I think it would have been better if we discussed even rolling shutter parameters in the motion blur lesson. It's something that you would rarely use, and I think it was good that we got it out of the way. So these were general settings for Arnold Camera Node, and in the next lesson we take a close look at the depth of field effect. So see you there.